Welcome back to the Packet Lab. Today we're going to take a look at another in the OSPF series of lessons, and today's lesson is going to concentrate on an advanced OSPF feature, which is Incremental Shortest Path First, or ISPF. So to understand Incremental SPF, we need to recall how OSPF builds the shortest path tree from the LSA. So it's going to go ahead and run Dijkstra's SPF algorithm on the LSAs that it has, and it's going to come up with a computation that's going to build what is called a SPT, or shortest path tree. So each router's going to build a tree that describes the entire network with itself as a root. So basically it's saying, you know, like I live in Minneapolis and I want to know how to get to Washington, Seattle, and Los Angeles. I don't need to know how to get to Washington, Seattle, and Los Angeles from Walla Walla. I need to know how to get there from Minneapolis. So when I start mapping stuff, I'm going to make myself the route and say, okay, to get to Seattle, I go west until I hit the Pacific Ocean. Anywho, so that's what the routers are going to do. They're going to do this on each router, and they're going to make themselves the route. And it's probably easier to show you this. Okay, so what we have here, it's pretty simple topology, and we'll touch on this obviously when we get to the magical slide 10. But here R1 is up here, and here's our topology, and we've got, you know, R1 through R5. So when R1's looking at the network, it's going to say, okay, to get to R2, pretty easy, only one link to get there. To get to R3, well, there's multiple ways I can get to R3. I can take the direct path from R2 to R3. I can go from R2 to R5 to R3. I can go from R2 to R4 to R5 to R3. So there's multiple different paths. What it's going to do is it's going to look at the LSAs. It's going to run the SPF calculation, and it's going to say, well, you know, here's the best path. So when I build my tree, I'm only going to have the best paths, and that's how I'm going to eventually populate the routing table. So let's take a look at this. Okay, in this case, this is the SPT, shortest path tree, that gets built on R1. So R1 says, hey, I'm the route. To get to R2, well, I only really have one path, so that's how I'm going to get there. To get to R3, I'm going to go through R2 to R3. Now you notice you don't have any alternate paths. You don't have that path from R2 to R5 to R3 or R4 to R5 to R3. So it's just giving you the best path. So where ISPF comes into play is that if you've got this shortest path tree built and you have a problem between R2 and R3, say this link goes down. So what normally happens is that SPF is run again, and it goes through all the LSAs and builds this tree again. Now it may have another path to R3. It may say, okay, well now I can't reach R3 at all, but it's going to be working to fix this branch of the SPT, of the shortest path tree. Well, when this happens, the rest of this tree here, the branches from, you know, R1 to R5 and R1 to R4 and R1 to R2 are not affected. It's just that branch from R2 to R3 is affected. So how ISPF comes into play is that it's going to say, you know what, we really don't need to be running the calculation on the entire tree, taking up time and CPU resources. What I really want to do is just run the calculation on this branch of the tree, see how I fix this part. So what it's going to do is it's going to actually have stored the entire shortest path tree in memory. So when it gets an LSA that says, help me, help me, help me, the path from R2 to R3 is down, instead of going ahead and rebuilding the entire tree from scratch and saying, okay, well, let's look at all the LSAs and build this sucker, it's going to say, all right, well, let me compare what I have in memory for the shortest path tree. And when I look at that, I see that this link that's down is only affecting this one branch. So I'm just going to recalculate for this branch. And that's going to save you CPU utilization because it's not going to be running the entire calculation. And it's also going to save you time. Again, it's not running the entire calculation, so you're going to get your results back a whole lot faster. All right, back to our slide. Now this slide, all this information was taken directly from the Cisco documentation, so that's why the writing is a little Cisco-esque. So what I've just described to you really describes the first half of this first paragraph. Actually, all of the paragraph. The only thing in here is the note if the changes to Type 1 or Type 2 LSAs. I suppose I should go into that. The changes for Type 1 and Type 2 LSAs, if you remember back, every device that's running OSPF is going to generate Type 1 LSAs. Type 2 LSAs are created when you have links that require a designated router or a, well, designated router basically, and a backup designated router, although those two go together. So that's when you can have the Type 2 LSAs. And the last bit here is saying that if there is a change to the Type 1 or Type 2 LSAs on the calculating router itself, so in the case if you look back to the one that we just showed you, if R1 has a change with its own Type 1 or Type 2 LSAs, then it's not going to use ISPF. It's going to go ahead and rerun the entire Dijkstra calculation on there. And then this last bit, it says incremental SPF is scheduled in the same way as full SPF. That just means that, when you have scheduled recalculations, I believe that's every 30 minutes or whatever, I can't remember off the top of my head, it's still going to do that. And it's going to say routers enabled with ISPF and routers not enabled with ISPF can function in the same internetwork. You can enable this feature on a per router basis. Well, the easiest part of OSPF Incremental SPF is the configuration. It's dead simple to configure. You just need to know 4 frickin' letters. So you go into the router process. In this case, we're on R1. We go under router OSPF process 1, and then you type in ISPF, hit enter, booyaka, booyaka. This sucker is now configured. And we're going to verify this by issuing the show IP OSPF command. Hit enter. This gives you a butt ton of output. What we're looking for is this bit down here where it says incremental SPF enabled. So like I said, this is dead easy. You just have to remember that it's configured under the routing process. And the command is super easy because it's the abbreviation of the feature. Next, we're going to take a look at a couple commands. These aren't really verification commands. I guess they are. What these commands are going to do is it's going to show you information about the SPF calculations. So this could be a verification command to make sure that your ISPF is working, or it could also be a troubleshooting command to say, hey, I probably should implement ISPF, or, I've got some problems with my SPF calculations. So the first of these is show IP OSPF statistics. And what that's going to do is it's going to give you this nice table, and it's going to show you the last 10 SPF calculations in backwards order. So this delta T, that's going to tell you the difference in time from when this was run into the current time. So the smaller this is, the more recent. So the bottom calculation is going to be the most recent. We can see the most recent was 11 minutes and 33 seconds ago. And then what it does is it shows you the pieces of the SPF calculation, how much time they took. So each of these can be basically paired. You got intra-area calculation, then D intra-area, that's deleting the LSAs. So if you had to remove some inter-area links, it would be under this D. Same thing with summary. Those are your inter-area and D summary. And then external are your Type 7 external, which is external and D external. And then the total is going to be the total amount of time that it took for the SPF calculation. And then we have a reason code over here. And the reason is going to give you basically the LSA type that triggered the calculation. You can see here that most of these are R. R means router, which in Cisco speak is type 1 LSA. And you can see down here, this guy had a bunch of these. And we'll go through what these codes are in the next slide. Anyways, the most important information from here is seeing, A, how many times has this calculated recently? If you've got 10 calculations within, 10 minutes, there's probably some network topology changing on quite a regular basis. Generally, if everything's running normally, you shouldn't see this thing change very often. And then the second thing that you're going to really want to key in on is the total amount of time. So here we're looking at 8 milliseconds, 12 milliseconds. These last two dogs were only 4 milliseconds, so they weren't as bad. And then if you want to get a little bit deeper in, you can see what type of LSAs are causing the recalculations. Oh, we actually had some. It's probably adding in. This is probably when I was building the network and I added in the externals. Anyways, I'm speculating. Those are the big fields that you want to take a look at. Okay, this slide's here for your reference. I'm not going to go through all these in detail because I pretty much described them in the last slide, but you can see all the different fields and what they mean here. Here's the reason codes here, and you can see here that R, which is a router LSA, type 1, N, which is a network LSA, type 2, SN, summary network, type 3, SA, summary autonomous system boundary router. I thought these were called like summary address as well, but anyways, that's LSA type 4, and then X is external, which is LSA type 7. And I have a little note here, which I probably should have read before I started speculating on that last slide. I have seen these right after enabling OSPF for the first time, even though no external LSAs are present in the OSPF area. So here's a sample with the show IP OSPF statistics. And this is just proving my point that when I first did this, that there was an X here and there were no external LSAs in that area. So if you see that, don't get too tripped out. So the show IP OSPF statistics command has a more verbose brother, which is invoked by just adding the details argument to the end of the command. And you can see here, rather than getting that nice little table, we're going to get information on each instance that the SPF calculation was run. So here it's only been executed one time, so we only get one output here. So it says SPF 1. That's going to be the number that corresponds to it. And of course, if it's 1, it's the oldest SPF calculation. Here it was executed 18 seconds ago, so we just brought this sucker up. This is going to come into play here with ISPF. It's going to say SPF type is full. So here we did a full calculation, which makes sense. We're bringing this guy up for the first time. Then we get the same fields that we did with the show IP OSPF statistics, SPT. That one I'm not sure on what that is, to be honest. But then we got the same fields here with the intra area, delete intra area, summary, blah, blah, blah. You know how this goes. This is the guy that we're keying in on. The total was 16 milliseconds, and that is made up of the sum of the intra area and deletion of intra area, which was 12 and 4 milliseconds, respectively. Gives you a little bit more detail here. It says that the LSIDs that were processed, 6 of them were R or router or type 1 LSAs, and then it gives you the rest. We didn't have anything else. Instead of using X, it now uses X7, and it does include stub as well. Stub is not a stubby area. I'm not going to get into this, but don't get confused on that. That doesn't mean that you have 12 stubby areas configured in OSPF. Here's the details of the change record. We had 6 LSIDs that were changed. LSIDs are going to basically be your router IDs. And here you go. You can see the 6 here. It's going to show you the last 10. So if this number was 15, it wouldn't show all 15. It would show only the 10. And you can see here, these are the router IDs for each of the routers 1 through 6. And then the R there means that the type of LSA was router, which is LSA type 1. So you get quite a bit of information in here. It's a little more detailed than the show IP OSPF statistics command. And again, this slide is for your reference. It shows all the different fields. So the SPT, this doesn't help me much. Time in milliseconds requires to compute the first stage of the SPF algorithm to build the short path tree. Short path tree, not shortest path tree, whatever. The SPT time plus the time required to process links to stub networks equals the interrupt, whatever the fuck. That doesn't give me a whole lot of detail. We saw that this was 0, so it doesn't really matter. If you want to take a look at this in your own spare time to figure out exactly what the hell this is, you can go ahead and knock yourself out. It wasn't that important to me. Here's all the LSID process. I think we went through all of this stuff here, so yeah, the last 10. Again, this is for your reference, but we did touch on all of this in the last slide. All right, so we know how to enable this. We know how to verify that we've enabled it. We also know how to verify that it's working and or troubleshoot our routers to verify whether or not we need ISPF. So let's take a look at the 3 different scenarios that ISPF is going to come in handy. And I'll read these off here. We're going to go through each of these in detail. We're going to have some beautiful visualizations, as well as we're going to go ahead and mock these up in Dynamips and do some CLI work here. First of these is the addition of a leaf node to the shortest path tree. Second is a change in a non-shortest path tree link. And then finally, we have a change in a single branch of the shortest path tree. So without ISPF enabled, each of these scenarios is going to trigger a full SPF calculation, and we already know the bad juju behind that is it's going to eat up CPU resources, as well as take longer time to converge. With ISPF enabled, each of these will result in a partial SPF calculation, which saves us CPU cycles as well as convergence time at the expense of a little bit of memory here. So let's jump in and take a look at the first of these scenarios. Okay, so we've seen this slide before. This is our topology. Pretty simple here. We've got R1 and then we've got R2 through R5. Is that a full mesh? No, it's not a full mesh because there's no connection between R3 and R4. It is a mostly full mesh if you would prefer. Between these routers down here. So what that's giving us is it's giving us multiple possible paths to these endpoints here. So from R1 to R2, there's only one path. You got to go down this road. But if, like we showed earlier, the example for R3, all things being equal, you go from R1 to R2 to R3, and that would be the simplest path. But it could be the case that you've got faster links or some other cost benefit going through other paths. So you go from R1 to R2 to R5 to R3, or R1 to R2 to R4 to R5 to R3. So the only reason I'm showing this is because when you build the shortest path tree, you're only going to have the best path. So let's take a look at how that SPT looks here. And we've seen this guy before here, but this is going to be the simple SPT here. And you can see that what we've done is we've calculated the paths, and we don't need to bother with all those redundant links here. We just need to know how to get from R1 to each of the endpoints here. And if this was on R2, the shortest path tree would look different because R2 would be the root rather than R1 and R4, whatever. You could visualize what they would look at by just popping this guy up here and keeping the same connections. Anyways, so to get to R3, we're going to go through R2. We're not going to deal with any of the links. So we've seen this before, but that's just showing you how the shortest path tree looks in comparison to a physical topology. Now, imagine that we had thousands of routers. This SPT could get pretty complex here. Okay, so we're looking at our topology again, and the observant amongst you may have noticed that we've added a router. Down here, we've added R6 to our topology, so we just have a single connection from R3 to R6, and this is our first scenario where ISPF is going to come into play. And it'll probably be better explained by looking at the resulting shortest path tree, which we will do in the next slide. Okay, so here's the shortest path tree now that we've added R6, and you can see what's happening here is that we've added R6 down here, and it really hasn't affected anything. It's just adding a single node here. None of these other branches, and that's what we're going to be referring to these as, has been affected. It's just this link here. So continuing the analogy of a tree, this guy would be considered a leaf. It's just, you know, a single connection at the very end of a branch. So without ISPF enabled, when we do this, we would run the full SPF calculation, and we're concentrating on R1. This would happen on all the routers, but we're concentrating on R1 for this example. And so then you would waste CPU resources and network convergence time because it's going to go ahead and recalculate all these. Well, it really doesn't need to recalculate any of this except to add the R6 on there. So with ISPF enabled, it's going to say, well, let me just recalculate this. And it might recalculate this entire branch just to get to R6, but it will not touch any of this stuff here, you know, the connection to R5 and R4. So we're going to save CPU resources because the calculation is going to be simpler. We're also going to save time because it's going to run faster. We will lose a little bit of memory because the way ISPF works is it's taking the previous shortest path tree, you know, which is everything except R6. It's keeping that in memory, and then it's going to look at this and say, oh, what is this affecting? It's just affecting this. So you do lose a little bit of memory here. I suppose I should mention, I haven't mentioned it explicitly, I'll pop back to the topology here, that all the topologies here are going to be in a single area. I don't have the area circle or anything. All of these are going to be single area. So all these guys are in the same area. We'll make it area 0 just to make it easy. Okay, so this is scenario 1 without ISPF enabled. So what we're going to do is we're going to bring up R6. We just did a no shutdown on its 00/0. It joins the network. And now on R1, when we do a show IP OSPF statistics detail, we can see that this SPF algorithm has been executed 6 times. So we're going to go and hit our spacebar till we get to the end of this. The last one is going to be the most recent one, and we can see it was executed 5 seconds ago. And here's what we're keying in on. The SPF type was full. So this is without ISPF enabled. So we added this router and it went ahead and did a full shortest path first calculation. And you can see here that it took 8 milliseconds for the intra area, and that's all there is. So the total was 8 milliseconds. There was 2 records changed, and this makes sense. R6 joined the network, and then R3 was a connection that R6 came up on. So 2 Type-1 LSAs, and it took a total of 8 milliseconds and required a full SPF calculation. So let's see what happens when we enable ISPF, and we're going to just do this on R1. Again, you could do this on a router by router basis. We only need to do it on R1 for our circumstances here, just for comparison. Anywho, let's get to it. Remember how easy this was? We go in R1 and we go into the router process. We type in ISPF and we hit enter. We're going to go ahead and verify this with the show IP OSPF command. We don't want to see all the additional output, so I'm just going to grep to include the word incremental with a capital I. Remember that your grep commands are going to be case sensitive, and we get incremental SPF has been enabled. So we verified that this has been enabled. So we go under R6. Oh, I suppose I should mention that R6 had been shut down once again, so we were back to our topology without R6 in it. So to bring it back up, we do a no shutdown on interface 00/0 on R6. That adds R6 to our network. We're going to go ahead and reissue on R1 our show IP OSPF statistics detail, and we see here that it's run a few more times. It's been executed 11 times. Doesn't matter, we just want to see the last one. So we hit spacebar till we get down to the SPF 11. This was executed 52 seconds ago, and the SPF type is incremental. This is what we're looking for. So rather than being full, it is now incremental. So we're only doing a partial SPF calculation, and as we looked here, that's interesting, it's deleting intra area. Not sure why that is, but anywho, what we see here, we don't need to worry about all that garbage. What we're looking here is the total. So the total now is 4 milliseconds. So it ran a partial SPF calculation, and it took 4 milliseconds, which is half the time of the full SPF calculation. So not a big deal here. You know, we're looking at milliseconds, but if you had, you know, a huge network, this savings in time can be significant. And where you're saving in time, you're also saving in CPU utilization because you're only running a partial calculation. And we can see here, the different LSAs that are processed. Again, stub is not a stubby area. It's a link type. And the only LSA changed was the router LSA on router 6. So the big takeaway here is that we're only running an incremental SPF calculation, and we have actually made our total time to recalculate the network. We've cut that sucker right in half. All right, so here we are on the CLI. We've got OSPF running on the topology that we just showed you. Everything is up and connected except R6. If I do a show IP OSPF, let's go ahead and just see the whole output. You can see there's a ton of stuff that comes out here. What we're looking for is right here. So by default, incremental SPF is disabled. And if you do a show run section router OSPF, I don't need to do a do because I am not in configuration mode. Okay, you can see this is just a plain Jane OSPF configuration. We've thrown everything into area 0, and this is the same configuration that's on all the routers. So we got all our routers running. If I do show IP route OSPF, you'll see we've got a ton of different routes here. These are all the routes on all the different routers. The only one that's not up right now is R6. I've got the connection between R3 and R6 manually shut down. Ping 5.5.5 just to show you that we do have connectivity. Anyways, let's go ahead and take a look. We verified that we don't have ISPF running. Let's take a look. Show IP OSPF statistics. And you can see we just brought this up. So the algorithm has been executed exactly one time, and that was about 6 minutes ago, and it took a total of 12 milliseconds. Let's go ahead and take a look at the detail here. And you can see it's the same information here. It's going to give you this. We only have one SPF instance, so it's only going to show us the one, but it shows us the same stuff. Now it's 6 minutes and 43 seconds ago. SPF type is full, and we expect this, A, because this is the first time it was run, and B, because we don't have incremental SPF enabled. And you can see here, get a little bit more, well, actually it's the same detail that was up here. See our 12 milliseconds. Shows us the LSIDs that were processed. 5 were router, which is LSA type 1. Stub is the type of link. Don't worry about that. And then it says the LSIDs that were changed. Well, yeah, we learned about all our neighbors. And it shows these 5. If there were more than 10, it would only show 10 of these, but we don't have more than 10 routers running here. So this would be where you would look if you were having problems. If you're like saying, well, why is my CPU getting eaten up? Why is my routing convergence time so high? You could use this command, either one, the show IP OSPF statistics, and then of course the detail to get more details. And you could determine, if you have the SPF running a ton of times, if it's running every few minutes or seconds or whatever, something's going on in your network. Either it's related directly to OSPF or it's a topology change that's triggering the SPF, and you could determine from here whether you want to troubleshoot that, or in this case what we're going to do is we're going to go ahead and enable ISPF to at least minimize the effects of these topology changes. So speaking of topology changes, let's pop on over to R6. I'm going to get into configuration. I'm going to do IP, show IP, interface brief, exclude assigned. And you can see here that 00/0 is administratively down. So what I'm going to do is I'm going to go into that interface and I'm going to issue the no shut. That's going to bring that up. We should see a message here saying that the OSPF neighbor is up. Interface comes up, and there you go. We got an adjacency. So what we've done now is, if you remember back to that topology, is that we've added R6 connected to R3. And what we've done with the shortest path tree is we've added a leaf node on that connection. So now if we go back to R1, let's go ahead and let's do a show IP OSPF route. It's show IP route OSPF. Otherwise you're looking in the LSA database. I've done that a couple times now. And we can see that we do have a route to router 6. Let's just make sure that guy's up. So now let's go ahead and do a show IP OSPF statistics, and I'm just gonna abbreviate this. So now you can see that our last change was 48 seconds ago, so that's when we added R6. So let's go ahead and take a look at the details on this. And now you can see the algorithm has been executed twice, so we have details for each one, which is pretty cool. What we're looking at here is the second SPF instance was a full calculation, and it took 8 milliseconds, which is less than what it took to build the entire network. And you can see the LSAs that were changed. Looks like a couple on R6, which makes sense. You got your loopback and your connection to R3, and that's probably your 3 records. That's what happens out of the box without ISPF enabled. So what we're going to do is we're going to go back over to R6, and we're going to go ahead and shut this guy down again. And while that's baking, we will go ahead and get into configuration mode on R1, and we go into router OSPF process 1, and then the command. Hit enter, or I'm sorry, if you invoke the Cisco iOS help with the question mark, you can see we got quite a bit of stuff here. This is what we're looking for. It says enable incremental SPF computation. So ISPF, hit enter. We're going to break out of configuration mode. And the first thing we're going to do, I strongly recommend that you get into the practice of doing this, whereas you configure something and then you verify the configuration. Now, we can verify this a couple of different ways. We could do a just a show run section router OSPF. And you can see here that we do have ISPF enabled. The verification show command is show IP OSPF. And we get a ton of output. What we're looking for is right here, incremental SPF enabled. So if you want to just get that output, you can grep for just incremental, and you don't even need the whole word, just the first few letters. And you can see here that we verified that we have enabled incremental SPF. So we do show IP OSPF statistics. Yeah, this is our last change right here, and that was when we shut down that interface. So now what we're going to do is we're going to go back over to R6, and we're going to do a no shut, and we'll wait just a second here. We should see the interface come up, which we do. Protocol comes up, and now we're just waiting for our OSPF adjacency, and there you go. So now if I go over to R1, I should probably be able to ping 6.6.6, which is the loopback address of, see that? It's still thinking. There we go. Got it. All right, so we now have that route, which means we should have built our SPT, our shortest path tree. So now if we do a show IP OSPF statistics, you can see here, here's our last change, and that was 14 seconds ago, and it took 4 milliseconds. Wow, that's pretty fast. Let's take a look at the details here. Now we've got, we're up to 6. It's been executed 6 times. So the nice bit is that the newest computations are at the bottom here, and actually, we have 2 computations. I'm not sure why that was. Must have been the order in which the LSAs were received. But you can see here what we're looking for is the SPF type is now incremental. And if you see here, it was 4 milliseconds. And if you remember before that, when we made the change, it was 8 milliseconds. So we've actually cut our time in half. And it gives us the same information. But what it's done in this case is it's not running the full SPF calculation. It's just running an incremental SPF calculation, which is just on that one branch. Okay, so that was our first scenario, which is the addition of a leaf node to the shortest path tree. Let's go ahead and take a look at the second scenario, which is going to be a change in a non-shortest path tree link. Okay, so the topology for this is going to be extremely similar, except we're not running R6 here. So then the shortest path tree that will be built on R1 will look like this. It'll have, a link to R2, and then the individual links to R3, 4, and 5. So now the spanner that we're going to throw into the works is that we're going to go ahead and we're going to take down this connection between R3 and R5. Now looking at this and remembering what we just saw for the shortest path tree, this is not part of the shortest path tree. Shortest path tree is going to be R1 to R2, R2 to R3, R2 to R5, R2 to R4. These 2 links here, the one from R3 to R5 and R4 to R5, are not used in the shortest path tree. So by changing this, by making this topology change, we're not affecting the tree whatsoever. So we really shouldn't need to rerun the entire shortest path first algorithm to get back to the tree because nothing has been changed. So using that scenario where we are shutting down that non-shortest path tree link from R3 to R5, in this case, it looks like I had a different topology because I had a fast Ethernet. But anyways, just pretend that's a serial 0/1, I guess, in this case. Go ahead and shut that down. And when we take a look at our IP OSPF statistics detail, what we see is that the last execution, so we see it's been executed 14 times. And so we go to look at SPF 14, 22 seconds ago. It was a full SPF calculation, which makes no sense because absolutely nothing has changed. Not only that, but it took 12 milliseconds. So again, we're looking at small topology. If we had thousands and thousands of routers, this would take substantially more than 12 milliseconds. And let's say that this isn't even just down. it's flapping, it's bouncing up and down multiple times per second. So you keep running the SPF algorithm, a full SPF algorithm, over and over and over again every time that flaps, and you're just eating up CPU resources, and for no good reason. All right, and this is a look at the same scenario, but this time we have ISPF enabled. I suppose I should have put in a bit of configuration here that showed ISPF being configured on R1, but you know how that's done. So anyways, go ahead and recreate the same thing where we shut that down. Now we take a look here. It's been executed 19 times, but now the last SPF execution was incremental, and we take a look here, and here's the number we're looking at. So it's 4 milliseconds. That's 1/3 of the time that it took the full SPF calculation. So you're saving quite a bit of time here, especially in a situation where the shortest path tree does not change one iota. So this is actually a really good implementation for ISPF. Okay, so let's see this scenario in action. What I did was I went and shut down the connection to R6. We don't need that guy for this scenario. And then I went back. You can see here that I disabled ISPF on R1, and I could prove that by doing show IP OSPF, include INCRE, and you can see it is disabled. So now what we want to do is we want to go over to R3, and let's go ahead and do a show int description, and I want the one going to R5. Okay, what's going on here? Oh, I think I know what's going on. 1 second. All right. Well, in my brilliance, when I built this in GNS3, you can see what I did differently. I put R4 here, which is probably where it should have been in the first place. So it's the same SPF tree. It's just that R4 and R5 have swapped. So what we're going to do is we're going to shut down the connection from R3 to R4, and that will emulate the same situation that I saw you. So the topology in the slides doesn't exactly match up with what I've got running here, but I think that you guys can stick with me here. It's not that different, just R4 and R5 have swapped. Okay, so that being said, let's go ahead, and what we're going to do is we're going to go under interface 00/1, and we're going to shut that bugger down. So we've shut down that redundant link. Our shortest path tree will be the same, nothing's changing here, but if we go back to R1 and we go show IP OSPF statistics, and we could skip this and go straight to the details because we're not going to see whether it was a full SPF calculation or an incremental simply by the show IP OSPF statistics. We need the details. And we can see here now we're up to our 10th SPF change here, and we'll just spacebar till we get to the bottom here. And here's our last change, and you can see here that the SPF type was full, which is just really kind of a waste of resources here because we really don't need to have a full SPF change. 6 seconds ago we had a full change. So let's go ahead and bring this guy back up. We'll do a no shut, and while that's getting all of its OSPF goodness back together, we'll go under the router process on R1, and we will issue ISPF, break out of that. Again, I always like to verify that what I typed in actually took, because a lot of times I screw it up by fat finger, or I don't hit enter, or something goofy might happen. It's good to make sure, and here we see that incremental SPF has been enabled. So now let's go ahead to R3 and see everything came back up. You can see that the interface is back up and it's got its neighbor relationship. Before we do this, go ahead and, well, pinging's not going to really help. Here's what we'll do. We'll do a show IP OSPF stat detail, and again we should see a full SPF calculation. That's because this happened before we applied the ISPF configuration. So now we should see SPF 13 when we go ahead and do this and shut this bugger down. Pop on over to R1. Let's see if we see 13 times. We do. There is a limitation here with the show IP OSPF statistics. Even though the algorithm is executed 13 times, you're only going to see the last 10, which is generally good enough. We can see the last one was 10 seconds ago. And let's pop back over here. And it looks like when we're adding and removing ISPF, we're getting this reason code where it's using all the different LSA types. So RN, SN, SA, and X. That's LSA type 1, 2, 3, 4, and 7. So that must be what's triggering that. I attended a session, a troubleshooting OSPF session when I was at Networkers, and they told us what triggers this, and I thought it was when you clear the IP OSPF process, but I don't think that that's absolutely true. I'll look it up. Anyways, let's go ahead and take a look at this, but let's take a look at the detail. And what do we expect to see here? Booyah, we see incremental. So it looks like this is handling this a little differently. I'm not sure why it's doing this in 2 steps. It's probably because what it's doing is it's seeing the link come up. It's getting the LSA for the link between router 3 and 4. And then once OSPF has started exchanging routes, then it's going to go ahead and see R4's loopback LSA come in there, the 4.4.4.4 address, because it's not going to see this because it's not directly connected. It has to be propagated via routing. So maybe that's why we're getting the 2 separate SPF calculations, because it's saying, okay, I'm going to run SPF because I've got the LSA showing me this link between R3 and R4, and then a little bit later, oh, look at this, another LSA came in that I learned via the routing process. Oh, I learned once OSPF routing had been enabled. Either way, it's incremental. In this case, it didn't save us a whole lot of time. Well, about half of that. Actually, this last one took no time whatsoever, and that's probably when it learned that LSA, because there was no topology. I mean, you ran this, and to add that LSA really takes 0 time because it doesn't change anything. All right, hopefully I didn't get too far off the beaten path there. Let's jump back to slides and take a look at our last scenario where ISPF comes into play. Okay, and then the third scenario for ISPF is a change in a single branch on the shortest path tree. And we got the whole gang back together for this topology. We've got all 6 routers here. Here's what the shortest path tree is going to look like on R1. You can see that we have 3 different branches off of R2, each going to R3, R4, and R5. And again, remember, when I have this built out on Dynamips, R4 and R5 are actually swapped here. Okay, so here's our third scenario. So we're going to take down the link between R2 and R3, and that's going to break this connection. We'll actually still have connectivity to these 2 routers because we still have a connection from, well, in this case, again, R4 and R5 are swapped. R4 and R3 have a connection, and then R3 can connect to R6. So basically what's going to happen is that this portion is going to get added to this branch, and then this branch will not exist anymore, but this branch won't be affected whatsoever. So this is a case where it's affecting an entire branch of the shortest path tree, but it's only one branch. The other 2, well, you could make the case that this one's going to be affected because it's going to be added to. But this guy, for sure, nothing's going to be changing in the path between R1, R2, and again, R4 is actually R5 in Dynamips. So let's take a look at this guy in action. And I'm going to skip the slides. The slides are there for your reference, but we're basically going to do the same exact thing on the CLI, so you'll see all this. Okay, so I've brought up all the connection. Everything is back up. If we do a show IP OSPF, no, show IP route, OSPF. You could also see here on R1 that I did disable ISPF again. We should see everything here, and I should be able to ping 6.6.6, which is the loopback interface on R6. So all the routers are up, all the neighbors are established. If I do a show IP OSPF, include INCR, we'll see that Incremental SPF is disabled. I do a show IP OSPF statistics. You can see we're really adding to the number of times that this SPF algorithm has executed. In normal operations, it's not going to do this. This is us dinking around in a lab situation. What I do want to show you is that to clear this, there's really no good way to clear this. So if I do a clear IP OSPF and the question mark for help, there is an option for counters, and you would think that that would be it. But then if we go ahead and take a look, didn't do a damn thing. Clear IP OSPF process. See what that's going to do is that's going to take down your neighbor relationship and then rebuild it. Did it pretty quickly here. You really don't want to do that in production unless you know what you're doing and you've got all the monkeys above you to sign off on it. But this thing I want to show you here is that it still does not clear this. So the only way to really clear this is to go into configuration mode, and I'm going to go do show run section router OSPF. Why I'm doing this is I just want to get the existing OSPF configuration. When you're doing this in production, it's a good idea to do this. In this case, it's just going to really simplify stuff, because what I'm going to do is I'm going to do a no router OSPF1. That's going to completely blow away the configuration for OSPF. So now we have no OSPF running on here. And the reason I did this is because it's easy to just highlight this and paste it in there and restore it. So we'll wait just a second and we should have our OSPF neighbors back up. So now if I up arrow and take a look at my show IP OSPF statistics, we've cleared it out completely. So now this is the first time that we've run it, was when we stripped it out and re-enabled it. I'm doing this just to make this a little cleaner. In real life, you don't want to do this. I mean, it's not worth the effort to clear it out, but we would have had 18 entries on our show IP OSPF statistics detail, and I just want to kind of make this a little cleaner so that we can find what we need. So that being said, let's go ahead and implement our third scenario. And if you remember, that is shutting down the link between R2 and R3, which is going to just take a chainsaw to this branch of the shortest path tree. So let's pop on over to R2. I'm going to get into configuration mode. I'm going to do show int description. I could do a show IP OSPF neighbor. I could do a show CDP neighbor. Anyways, I just want to really quickly get the link that goes to R3, and it looks like it's going to be 00/1. So under 00/1, I'm going to go ahead and shut this bugger. Alright, so what that should have done is that should have changed the topology, which means we're going to have an SPF calculation, and I'm back on R1, and you can see here now we have the SPF algorithm having executed twice. Last time was 10 seconds ago. Let's go ahead and take a look at the detail, and we're taking a look at this last guy here. Well, now it's been 19 seconds because I've been blabbing for 9 more seconds, and it's a full SPF calculation. So you know what we're going to do here. No shut. Bring this guy back up. While that's thinking, I'm going to get in here and I'm going to figure ISPF on R1. Exit out of there. Now let's see. Show IP OSPF. Include incremental just to verify, and I did what I thought I did. Now let's do a show IP OSPF statistics. And you can see here that 2 seconds ago we had a topology change which triggered an SPF calculation. I think that's right here, that when you're adding and removing ISPF, it's going to give you this reason code here. But let's go ahead and take a look at the details. And remember this change here, well, we really don't care about this change, to be honest, because it's not the change that, we are making, we have to go back and make. So what we've really done is reset the topology and added ISPF to R1. Now let's go ahead and shut this guy down. We'll wait for it to tell us that everything has fallen on its face. And let's go ahead and reissue the show IP OSPF enter our statistics command. And here we go. We see one from 6 seconds ago. So now let's go ahead and do details, and you know what we're going to see here. It's executed 7 times, so we're looking for SPF 7 and exactly what we thought we would see, incremental. And here you see that 6 was incremental as well. This is probably that whole deal where it's getting LSAs not all grouped together. They're coming in a couple of waves here. But the important takeaway here, as it has been from all of these scenarios, is that by implementing ISPF, you are changing the shortest path first calculation from full to incremental. And you can see here that it took 8 milliseconds, and here it's taking 4 milliseconds. Of course, these really aren't good to compare head to head because this took 8 milliseconds, even though it was incremental. But you'll have to trust me on this. It will reduce the amount of time that it takes for the SPF calculation. All right, and then these slides just describe exactly what we just did on the CLI. By default, you're doing a full SPF calculation with scenario 3, and it took 8 milliseconds. Here's the same scenario with ISPF enabled, and you can see here that it took the same amount of time as without ISPF. Not exactly sure why that is. It might be because the amount of changes is significant enough. So maybe this one doesn't give you that big of an advantage. We did kind of kill one branch and then shift the nodes from that branch under another branch, so maybe it took a little bit longer. But okay, so this is a case where we saw that little blurb from the Cisco documentation that if the LSA type 1, type 2 change occurs on the calculating router, even with ISPF enabled, we're going to see a full SPF calculation. And we can pop over real quick and emulate this. I don't even think we need to rebuild the, yeah, we don't. I was going to say we don't need to re-enable that link between R2 and R3. Doesn't matter. If we go ahead and do a show IP OSPF, include incremental, you can see that ISPF is enabled here. What we're going to do here is we're going to go under our configuration on R1. Now remember, this is the root. This is where the shortest path tree is being built. And we're going to go under interface loopback 0, and we're going to shut it down. So we've made a change on our router. So now if we go and do a show IP OSPF statistics, you can see that 9 seconds ago we did have an SPF calculation. And now let's go ahead and take a look at the details. So we're going to look at SPF 9. Here's what we're looking for. So we made a change on our router. We are the router where the LSA change was made. And we see this here because we've got our quad ones. That's our router ID here. And because we were the router where the change was made, the SPF type is full, even though we have ISPF enabled. So keep that in mind. Probably won't show up too much in the real world, but it can throw you off where you're like, well, wait a second, I have ISPF enabled. Why the hell am I still running a full SPF calculation? And that could be the reason. Okay, so this is going over the benefits of ISPF. We've seen the 3 scenarios where it's a benefit. It's going to provide you more of a benefit the bigger your OSPF area is, the more devices, well, actually, the more links that you have in that area, the more likely you're going to get a benefit from this. Modern routers, the 2800s, 3800s, the newer stuff, and newer is relative, they're not going to probably get their CPU pegged from SPF calculations unless you have a bunch of stuff flapping. Then possibly you could have an increase in CPU. So I don't know that you're going to get so much benefit out of that, but any benefit that you have, the CPU isn't being used for stuff like this, it's unnecessary, then it can be used for stuff that is necessary. The network reconvergence, we could see that in a couple of situations, the time that it took with the ISPF enabled was, a half or a third of what it would be normally. So you do get a benefit from that. We did see at least one case, and that was where the LSA change was on the calculating router, where ISPF does not provide a benefit because it's going to go ahead and run the full SPF algorithm there. There's some other cases here where, like if you're doing a clear IP route or something like that, where it's going to do the same thing, but you will get benefit in those 3 scenarios, and it may be enough to lead you down the path of implementing this. And again, it can be done on a router by router basis. One thing I want to show you really quickly, especially from a CCIE lab standpoint, because this is like a favorite for the practice exams, is to ask you to implement the ISPF feature. And they'll usually word it with something goofy like, oh, in the case that a leaf node is added to the SPT, we don't want to invoke a full SPF calculation. We just want a partial calculation. Somebody's going to describe that and you'll be like, oh my God, what is that? So you go to your command reference. The problem with ISPF is even if you know that it exists, maybe you're like, oh my God, I remember something about that command. Let me go check the OSPF commands. It'll show it on the Cisco iOS help as we saw, but if you go into the command reference, at least on 12.4, you can see here's our OSPF commands, and we should see something that says ISPF, but we don't, which is goofy because that exists. This is where it gets a little bit tricky because the command reference actually exists. There it is, ISPF. That's interesting. But if we take a look here, it exists under the ISIS command reference. So I suppose this could be for real world as well, though in the real world you probably just open up a browser and search for this via Google and come across it. But in the lab, you're not going to think to look under the ISIS commands, but that is where it's at. All right, last slide. Let's get this guy done. So OSPF runs a shortest path first calculation to build the shortest path tree, which is the SPT. Each router is going to run this because it's going to have all the devices running OSPF within an area are going to have all the same LSAs. So they're able to build the same tree. It's just that the root of each tree is going to depend on the calculating router. So if you're on R1, R1 will be the root. If you're R4, R4 will be the root. When there are changes in the network topology, any change that is made is going to require that the shortest path first algorithm be run again. So it's going to run a full algorithm. Now, as we saw here, there's some scenarios where you really don't need the full algorithm, that only a part of that shortest path tree is affected. And the 3 instances here are the addition of a leaf node to the shortest path tree, a change in a non-shortest path tree link, and then a change in a single branch of, well, presumably a multi-branch shortest path tree. So those 3 changes, they require only that a portion of the shortest path tree be recalculated, not the whole thing. So we can save some CPU cycles and network reconvergence time by only running the shortest path first algorithm on that specific portion of the tree that is affected. And the way that we can do that is by implementing a feature called Incremental SPF. And what that's going to do is it's going to allow us in those 3 situations to avoid running a full shortest path first algorithm and just run what's called an incremental or partial SPF algorithm on the portion of the tree that's affected. Now, the way that it's able to do this is that it stores the shortest path tree in memory. So you're not going to use as much CPU and you're going to have faster network reconvergence time, but you are going to lose a little bit of memory here because it does have to store that SPT in memory for comparison. So where it comes in real handy is when you have a large number of OSPF devices within a single area, because in that case, when you have a single link go down, it may or may not affect the shortest path tree at all, or it does just, a portion of a branch, or it might just be an addition where it's a leaf node being added. You really don't want to take the time to rerun the shortest path first algorithm for thousands and thousands of links when it could just be done for one or a few links, and it's going to save you a lot of time and CPU resources in those situations. And there are some cases where even where you have ISPF enabled, it's still going to require a full shortest path first algorithm to rebuild that SPT, and we saw a couple of those in the lesson. Another thing to keep in mind is ISPF does not need to be enabled on all routers. You can do it on a one-by-one basis. And that's going to about wrap it up. I guess one last note that I just mentioned in the previous slide is that if you're taking the CCIE exam and you're looking for the documentation for this, at least the command reference, it's actually under the ISIS command references and not the OSPF command references. Don't ask me why. That's just how it is. Anyways, thank you once again for joining me in the Packet Lab. As always, I hope this helps you on your route to becoming a network